Anshuman Tripathi here from our own English High School, Alain, and this is my science experiment on things that float and things that sink. But first, let us answer some questions that a friend Cosmo the robot has.
Hey guys, I'm Cosmo! So my first question is, what is density?
Well, Cosmo, density is mass per unit volume. And if a substance has higher density than water, it sinks in it. But if a substance has lower density than water, it floats on it.
Oh, thanks, Anshuman. Now my second question is, how is density different from mass?
Well, that's a good question, Cosmo. Mass is the measurement of the amount of matter present in a substance. But density is how much space an object or a substance takes up in relation to the amount of matter present in an object or a substance.
Thanks, Anshuman.
As you all have understood that, let's begin with the experiment. For this apparatus, we require an iron nail, then some objects which you wish to test, an iron bowl, and a glass bowl, and some water. So now let's begin with the experiment. Let's test the objects now and see whether they sink or float. So as you can see here, some of the objects sunk and some of them are floating. And you can see here that even though this iron ball is heavier than this iron nail, but still the iron nail sank and the iron ball is floating. Some of you might be thinking it's impossible. You guys might have been thinking the other way around. But let me clear your confusions, as the floating and sinking doesn't matter on how heavy or big the object is. It matters on density. Like I had said before, the iron nail had more density than water, and thus it sank to the bottom. But the iron ball, as you can see here, is floating because it had less density than water. So that's why it floated. So now let us move on to the next experiment and keep this aside. And let's get another bowl filled with water. And for this experiment we would require a carrot, some salt, and a knife. Check whether this piece of carrot floats or sinks. Guys, look, it sinks. So here is my observation I interpreted from this step 1. Let's take this carrot once more and let's cut it. Now let's check whether this piece of carrot floats or sink, and let's see if there's any difference between these two. I think it sinks a bit less and it floats a bit. Yes. And then here is my observation for this step 2. Okay, now let's take this carrot once more and cut it once again. Now let's check if there's any difference when we put this in. Yeah, I think look at it. I think it floats a bit, right? Yes. Okay, now let's just put some salt. Let's just put some salt into this and see what happens. So now I'm mixing the salt in. Okay, so as you can see, the salt is completely dissolved. And now let's try putting the same piece once more. Let's see if there's any change. Yeah, you can see it floating a bit, right? Just look at it. Do you know why that happened? That's because the salt occupied all the molecules. And here's an even better explanation to it. And this is the observation and a reason to it. So now let's wrap up with the observations. And this one, when we did it in the step 3, when we put it into the water that did not have salt, it still sank. But when we added salt into it, then it started floating, as you can see here. So this became less denser because the salt occupied all the molecular space, and thus the water started acting more like a solid than a liquid, and thus the carrot started floating a bit. Thank you.